So concave up is not necessarily a full cup. It's a curve like this, and concave down is it's just a bend downwards. Do you guys see that? Where concave up changes, or where the concavity changes from concave up to concave down, that is called a point of inflection. Okay, POI. That stands for point of inflection. Okay. There's some other pictures here where you can see what concave up and concave down look like. For example, do you see this is concave down? Like it's not a full frown. Does everybody agree with that? It doesn't have to be. It's just the bend of the curve is downward. And over here, the bend of the curve is upward. That's concave up. And where concave down changes, the concavity changes from concave down to concave up, that is called a POI. Okay. Over here, do you see how this could be called concave up? Do you see the bend is upwards? Do you see how the bend here is downwards? Okay, where is that point of change called? What is that point of change called? POI, which stands for what? Point of inflection. Okay, sometimes they'll be called inflection point. Okay, now some things I want to clarify. When we start trying to figure out where point of inflections are, sometimes we might have a curve like y equals 1 over x. And a lot of times you don't know what the curve looks like because it's too hard. But this one we know. And this one has an asymptote here and an asymptote here. Okay. Do you guys see that this is concave down? Do you see that this is concave up? Do you see at 0, x equals 0, you actually do change from concave down to concave up. But there's no point of inflection here. Do you see that? So just because there's a change, okay, first of all, a point of inflection always occurs when you change, oh, I don't know, it doesn't want to stick. When you change from concave down to concave up or concave up to concave down. But this is an exception, I guess, to the rule. You're changing from concave down to concave up, but this is not a point of inflection, and that's because there's no point. Does that make sense? When there's no point, you can't have a point of inflection, right? There's no point because y or x doesn't exist right here, okay, at the asymptote. Does that make sense? So there are some exceptions to the concave up, concave rule, one being there is no point, okay? Another one, like let's say if we had a picture that was concave up, and then it was concave up again. I don't know how to, probably, it could be smooth, I guess. If you change from concave up to concave up, that's not a POI either. Does that make sense? You have to move from down to up or up to down. Is everybody good with that? So POIs only happen when concave up, when there's a point, and at that point, you change concavity. Is everybody good with that? Okay, so that's a POI. All right, I want you guys to fill these things in for me. If you had a formal quiz, you would have to put these things in the blanks. But this is important that you know what goes in these blanks anyway. So guys, when f prime is positive, what do you know about f always? F is increasing. And when f prime is negative, what do you know about f always? Always is a definition. F is decreasing, okay? If f prime, that's the slope of that. If f prime changes from positive to negative, so you've got a slope that's positive and change to negative, what is there right there at that point of change? Relative mass, okay? And if f prime changes from negative to positive, what is that point right there called? Relative min. You feel comfortable with that? Okay. So what I want you to do is look at this problem here, and I want you to tell me what the answer is, A, B, or C. And just we're working with H prime here. You know how to draw an H prime number line. I'm going to give you maybe 30 seconds. Can you just tell me what the answer is A, B, or C? This is from your warm-up or from your notes. Okay, jot down your answer. Don't change it. Okay, I mean, you can change it after I tell you, but don't change it. Let's just see if you got the right answer. Okay, usually we work with F's, but here this is H's. Are you guys okay? It's the same thing. Okay, it's just a different name. If you want to, you can even just change this to f if you want to. Okay. It says the function's continuous, or f prime is continuous and has exactly two zeros. So what they're saying is, if you drew h prime, there would be two places. So let's think about h prime. There would be two places where you would have h prime is zero, meaning if I drew the picture, you know, the function would go through where y equals zero. So everybody good at that. H prime equals zero where y equals zero. So it's an x-intercept. Okay. And those two places, where would they occur? Can you look at this and tell me where they would occur at? At x equals -1 and x equals 3. You see where we're getting that? Those are the two places. And if I did an h prime number line, this says there are only two places where there are zeros. Okay, so those are the two places. And then it says h prime is continuous, so I'm assuming there's no place where you have d and e. Okay, all right. If the domain is all reals, where is h increasing? So this is an h prime number line. You guys good with that? So let's think about plus, 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 minus, minus, minus. Okay. Now, when we do plus, 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 minus, 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 am I talking about the x's being positive or negative, or the h primes being positive or negative? It's h primes. Everybody gets that. So in your mind, the thing about the h primes being positive or negative. Okay, so if you're looking at x is less than -1, can you tell me, in this compartment, should I put pluses or negatives? Negatives. Okay, but I just want to make sure we're looking at the same place. I am looking right here. I'm looking at the h primes. Are you looking at the h primes? Okay. Between -1 and 3, should this be plus or negative? Where are you looking? Are you looking, where am I anyway? Between here's -1 and 3. Okay, you should be looking right here. Are you looking right there? Don't look at the x's. Okay, you're looking right here. And so there's where I'm getting the pluses. Okay, this one's going to be a little harder. Beyond the 3, is it going to be plus or negative? H prime, plus or negative? Where should you be looking? Right here, right? Okay, so you get negative. And we know when h prime is negative, then h is what? Decreasing. When h prime is positive, then h is what? Increasing. And when h prime is negative, h is decreasing. Okay, so knowing all of that, let's answer the question. Where is h increasing? Okay, where is h increasing? So what's the right answer? A. Okay, now I'm going to tell you that the most common wrong answer on the test, okay, is B. I put a star by this. Make sure you look at it for the test. Okay, the answer is A, but the most common wrong answer is B. And the students who do B, let me show you what they do. First of all, they don't do a number line. Okay, they don't do a number line. They look at this and they say, oh, I see. There's a 0 right here. They'll circle this and they'll say, oh, there's a 0 right here. And I totally see what they're doing. Okay, and then they'll be like, oh, increasing. All these numbers are positive right here. So they pick 0 and 2. And do you see why they would pick 0 and 2? So they don't find the critical numbers. Does that make sense? They just pick the values that are between the critical numbers. Okay. So you're going to do that on the test? No. Okay. Pinky promise? Okay. Some of you guys don't keep your promises. Just want to say. Okay. This is going to be your test on Monday. You guys can take a picture if you want, and I'll talk about it. Okay. At the end of today, guys, this will be all the content you need for the test on Monday. Tomorrow we're going to do the second derivatives test, and that will not be on your test on Monday. That'll be on your next test. All right. All right. Mean value theorem, guys. There's 3 ways to talk about mean value theorem. Remember, I could just ask you, does it apply? Does it apply? Okay. And that means, is the function continuous on the closed interval or what? Differentiable on the open interval. Okay. So I could just say, does it apply? Okay. Second, what conditions need to be met so you can use it? That's the same thing. Does it apply? The second type of question is I can say solve for C. Do you remember that? That's MVT. What formula do I use? Do you remember? To solve for C. F prime of C equals F of B minus F of A over B minus A. Guys, you need to be able to write this without looking at anything else. Okay? Once you write that, then you just plug in. The number one wrong thing students do when they write this. Okay, first of all, The number one wrong thing students do is just not even knowing the formula. Everybody good at that. So please know the formula. But let's say you know the formula and you plug in, and let's say this is 5 and this is 2, this is 5 and this is 2. What students would do is they'll plug in everything. This is x squared minus 3x. Then they'll say this is 8 over 2 equals 4, and they'll stop right there and they'll say the answer is 4. Okay, what did I do wrong? I didn't solve for C. I didn't solve for C. Does that make sense? So make sure you solve for C. Is everybody good with that? That's the number one thing students do besides not even knowing the formula. Okay? All right. And then if I ask you what is the formula to satisfy the conclusion of MDT, make sure you know this red part right there is the formula. And here's another thing. You know, if I told you that f of x is equal to 3x squared minus 2x, okay, then if you were plugging into this formula here, what would you put? Oh, I didn't mean to do that. What would you put in for this right here? What would you put in for f prime of t? 6x minus 2. Everybody good with that? What if I don't tell you what f is? What if I tell you that f prime of x equals 3x squared minus 2x? Then what would you plug in for f prime of t? You would plug in the same thing. Does that make sense? If you take the derivative of this, so that would be f double prime. If you take the derivative and you plug this in here, do you see that you plugged in the second derivative and not the first derivative? Okay. Guys, a lot of times AP and me, we will give you the first derivative, okay, so that you don't have to find it. Does that make sense? And when I give you the first derivative and your formula says first derivative, please do not take the derivative again, okay? Please, you should just say, thank you, Ms. Chang. Does that make sense? And then put it right in. Are you guys ready for that for the test? Okay, so please make sure if you need the first derivative, if I give you f, then take the first derivative. But if I give you f prime, just use it. Okay, thank you, Ms. Chang. All right, implicit differentiation. Everything's kind of scooted over. Okay, implicit differentiation. If I give you a problem like this, okay, could you find the slope of this tangent line? It is a slope of the tangent line. Derivative. Could you find the derivative? Could you find dy dx? Could you find it? Okay, so please make sure you can. If you can't, then just go to your implicit differentiation worksheet. Go do one problem. Make sure you can do it. If you'll be good on that one. Related rates. There's 3 related rates problems on your test. If you take the first test, then the tangent theta problem will not be on it. Okay, so just FYI, I'll just pick 3 problems that you've seen before. Okay, the extrema problems. When I say extrema, do you guys realize what that means? Do you realize that extrema is extrema is a max or a min? Okay, it is not a relative max or relative min. Okay, if I ask you to find the extremas, then I am asking you to do a candidate's test. Okay, do you remember what a candidate's test is? All right. If I ask you to justify your answer, the candidate's test is your justification. Okay, you don't have to write any words. The candidate's test is your justification. I look at your candidate's test. I say, are your x's right? Are your y's right? You're good. Okay, that is the justification. If I ask you for a relative extrema, then what test are you going to do? The first derivative test. Okay, so relative extrema means relative max or relative min. Okay, or local max and local min. All right, the justification for that I'll talk about more later, but those require words. Okay, I will have review problems on your test. So far you've had 2 tests, and both of them had horizontal asymptotes on it. Your third test will also have horizontal asymptotes. So if you miss them on the first 2 tests, your time's a charm, okay? If you still don't know how to do them, I'll be here during 7th period and after school today, and we can do more of these together with you, okay? And you can also look at your own homework and do that. You need to know all your derivatives formulas, chain rules, product rules, power rules, all your trig formulas. You need to know the unit circle. You need to know this question. This question was on your last test. Most of you got it right, but some of you guys are still struggling with this type of problem here. And actually, I guess I could put a number in there. I could put pi over 2 or something like that. Minus sine of pi over 2 over h. Okay, can you tell me that answer? And that's an FDA problem. Okay, so if you don't know how to do it, we have a whole worksheet on that. Please go take a look at that and make sure you know how to do it. Okay. Some of these problems, guys, if you review it, it'll take you 5 minutes. You'll get it right on the test. Okay. Some of you guys are not reviewing. Okay. First derivatives test is what we did yesterday. Concavity test is what we're doing today. Those will be on the test. You need to know how to justify. I'll talk about justifying today. The IBT and MBT proofs. Do you remember that? Okay. Can you guys pull out your MBT worksheet? I think it's 1.3-4. I think. I'm not sure. It's the MBT worksheet. Okay. If you go look at number 4 on that worksheet, make sure you can do that. Okay.
It's -5.
Is it -5? Thank you. Okay, -5. Okay. Go look at number 4. Make sure you can do that. Your problem on test will be easier than that. You know how on number 4 you had to find your H's? I will give you your H's. Okay, I will give you your H's. But you just have to know when do you use IBT, when do you use MBT, and be able to do both of those proofs. You think you can do that? I feel like it's pretty straightforward. It'll be like number 4. Okay, except even easier because I'll give you your H's. Okay? All right. No calculator on this test. In a way, that'll make it easier. Remember, guys, if you have a free response question, and let's say you end up with this, I don't know, as your answer, okay, you can leave your answer like that. Is everybody good with that? I mean, you can, whatever, you can leave your answer like this. If you want to simplify it totally, you can, but if you want to leave your answer like this, you can. But if you have to take a derivative, you need to take the derivative. Okay, you can't leave your answer just like, Ms. Chen, you take the derivative for me. Okay, you gotta like take it down as far as you can. First derivatives test, this is what we did yesterday. When f prime is positive, then f is what? What goes in this thing, guys? Increasing. When f prime is negative, then f is what? Decreasing. Go ahead and put that in your notes. Okay, today we're gonna do the concavity test. And remember, I told you that f prime and f has that father-son relationship. Okay? But remember that grandpa and the father also has the father-son relationship. Do you remember that? Okay. So if I change this to the father, then wouldn't this just be the derivative of that? Right? So if I change this to prime, wouldn't this just be the derivative of that? Okay. And that is the concavity test. Look at the concavity test. The concavity test is when f double prime is positive, then f prime is increasing. When f double prime is negative, then f prime is decreasing. Okay. It is just using that same father-son relationship in the first derivatives test into another test. But the second derivative, or this is called not the second, this is called the concavity test. The concavity test has this one other thing, and that is it tells us that f is concave up, okay, if f double prime is positive, f prime is increasing. It also tells me that f is concave down. Okay, I don't know if you can read my handwriting, but that's concave down when f double prime is negative and f prime is decreasing. And just like the first derivatives test, these are all synonyms, okay? So I'm going to write this on a blank page, okay? You need to be able to, like, basically, when you get your test, I would like you to write this down, okay? For the next 2 tests, because we're going to be using this. When f prime is positive, f is increasing. Those are synonyms. When f prime is negative, f is decreasing. Those mean the exact same thing. If I say f decreasing, you say f prime negative. Does that make sense? If I say f prime positive, you're like, oh, that means f is increasing. Those are synonyms. Whenever you move from the top row to the bottom row, there is always a relative max on f, on the function f. Whenever you move from the bottom row to the top row, there is always a relative min on f. Okay, does that make sense to you guys? Okay, but this is also the justification. So if you ever say that there's, if you ever tell me that f is increasing, if I tell you justify it, you would say the justification is f prime is positive. Does that make sense? If you tell me f is decreasing and I ask you for the justification, you would say the justification is f prime is negative. You see how easy that is? This tells you all you need to know. If you tell me the relative max is at x equals 1 and I tell you to justify it, you would say the justification is because f prime changes from positive to negative. Do you see the justification? If you tell me the relative min is x equals 0 and I ask you to justify it, you would say the justification is f prime changes from negative to positive. Do you see how this tells you all you need to know? Okay, let's go to the concavity test. The concavity test, which you also are expected to memorize, is when f double prime is positive, f prime is increasing, and f is concave up. If f double prime is negative, f prime is decreasing, and f is concave down. When you move between these two rows, you have what's called a point of inflection. And it doesn't matter if you move between the top row and the bottom row, or the bottom row and the top row. It's still a point of inflection. Okay? So these are synonyms. So if I tell you, or if you tell me f is concave up, the justification will be, or the synonym will be, f prime is increasing. You see that? If you say f is concave down, the justification will be f prime is decreasing. Now, AP only wants you to use f prime as a justification. Okay? So don't use f double prime. Is everybody good with that? If you use f double prime, you're going to have to change it to f prime. So if you use this for the justification for f concave up, you would have to say the slope of f prime is positive. You see that? And that would be an okay justification. I just don't want you to use f double prime. They always want you to give me the justification in terms of f prime. Okay? All right, let's go ahead and do a problem. And all of this will be a lot more clear. Let's go to, on the bottom of your notes, there's some things that we can fill out. So can you guys probably already have it worked out. Okay, but you have this thing called test for concavity. I'm going to try to make this bigger so you can see it. Can you guys fill this in the blanks on your notes? Okay, so test for concavity. That's a little too big. Here it is. Okay, this first blank is increasing, and then this blank is concave up. And then this blank is decreasing, and this is concave down. You guys got that? Okay. Then you scroll up. This is a point of inflection. A point of inflection happens when f double prime is equal to 0 or f double prime is equal to d and e. So please write that down in your blank. You're not writing anything, so I'm not sure if you're listening. F double prime is equal to 0 or f double prime is equal to d and e. Okay? And then on number 2, it says f double prime changes signs. Please put from positive to negative in the first blank, or negative to positive in the second blank. And then down here, there's a mistake, I think. So change the or to a 2, okay? So you'll say if f prime changes from increasing to decreasing, or vice versa, okay? So please write all those things on. And then when you're done, look up and then I'll know you're done. Got it? Okay. So what we're going to do is we're going to use all of this to figure out concavity. I'll show you how to do this. So go look at your first problem. I think it's on the back of your paper. And this is your problem right here. We're going to review first derivatives test, and then I'm going to do concavity test with you. And this is how it works. Number 1A says they give you a function, and you want to know where the function is increasing or decreasing. And here you're talking about the relative extreme. These are key words, guys. Increasing, decreasing, relative max, relative min. That is always the first derivatives test. You guys good with that? So let's do the first derivatives test. Well, it's the first derivatives test, so let's take the first derivative. You with me on that? After I take the first derivative, what do I do with it? Find the critical numbers. Set it equal to 0 and set it equal to d and e. You with me so far? On the d and e side, you simplify it so you get all the negative exponents out. And do you see that on the right side, I'm going to get no critical values? Is everybody good with that? Because there are no denominators. On the left side, remember, you always factor or cross multiply. There's no fractions here, so I'm going to go ahead and factor. I'm going to take out a 4x squared, x minus 3 equals 0. Okay. Do you see I get something times something times something equals 0? Are you guys good with that? Okay. So that means one of these is equal to 0. That's real math, right, guys? So either 4 equals 0, oh, that's silly, or x squared is equal to 0, or x minus 3 is equal to 0, and that gives me x equals 0 and x equals 3. You guys good so far? How many of you guys think right here that this is saying x is equal to 4? Because I get that on the test all the time. People say x is equal to 4. Do you see that you're really saying 4 is equal to 0, not x is equal to 4? Is everybody good with that? So right here, how many critical numbers do I have? 2. Put them onto a what prime number, what kind of number line? F prime number line, okay? These are divided into 3 compartments. I'm going to find a number in each compartment, and I'm going to do the test. What's a good number less than 0? -1. What's a good number between 0 and 3? 1. What's a good number bigger than 3? 4. Okay. So I'm going to plug this into F prime. Is everybody good with that? Okay, not into F, into F prime. So I'm going to plug in -1. And if you guys are okay with it, I'm going to plug into this F prime. All right, it's a little bit easier to figure out pluses and negatives. So first I'm going to plug in -1. So do you see that that's positive times negative, which will be negative, right? Then I'm going to plug into 1. I'm going to plug 1 into here, which will be positive times negative. Do you guys get negative again? Which is negative. Then I'm going to plug in 4, which is positive times positive. Okay. Then I'm going to come through here, and guys, please do this. I'm going to cross out all my test points, because the reason is students are going to grab those test points and give them to me in the answer. And I promise you 3 of you will, okay, at least 3, if not more, on the test. So please cross out your test points. And what you get is when F prime is negative, F is decreasing. When F prime is negative, F is decreasing. And when F prime is positive, F is increasing. So that is a picture of what F looks like, okay? And really, if I were to draw this, it probably would be something like something going down, then zeros out, the slope zeros out. You guys, it's something that looks like that. If you could see F, like you could graph it on your calculator and see F, okay? All right, so here's the first question. Where is F increasing? So what I would do is I would say F is increasing on the interval, and so I look at my picture right here, on the interval from 3 to infinity. Everybody good with that? You could also say where X is greater than 3, either or. Let's make sure you know how to do the justification, because, and the justification would be this slide right here. F is increasing because F prime is positive. You see that? Okay, so you're going to write F prime is positive because F prime is positive. All right, let's do F is decreasing. F is decreasing on the interval. There's 2 ways you could write this. You could write from negative infinity to 0, and also from 0 to 3. Or you could write from negative infinity to 3. You see how both of those would be right answers, okay? So if you're doing multiple choice, make sure you're looking for both of those. Is everybody good there? What would the justification be for F is decreasing? Because F prime is negative. You guys good so far? All right, finally, what are the relative extremas? So do you guys see what the relative max is? What's the relative max? You guys good? There's no relative max. Everybody good with that? Okay. What is a relative min at? Where is the relative min? X equals 3. Is that right, guys? What would be the justification for relative min? Let me write it up here. Because F prime changes from negative to positive. Okay? If you don't see it, it's right here. It's right here. Relative min happens when F prime changes from negative to positive. You guys see where that justification came from? Guys, it's super important that you can justify. Okay, and then finally, let's see, did we answer all the questions? Good. So finally, now they're asking you, where are you concave up and concave down? So let me show you how to do that. Okay, concave up, concave down, POIs are second derivatives. Can you memorize that? Relative max, relative min, increasing, decreasing, first derivative, okay? Concave up, concave down, POIs, second derivative. So what we're going to do is we're going to take the second derivative, okay? You already know the first derivative. It's this right here. Let me mark it. Okay, that's the first derivative. So the second derivative is 12x squared minus 24x. Can you check me? Is that the second derivative? Okay. You're going to do the same thing that you did before with the first derivative test. You're going to set that equal to 0, and you're going to set this equal to dne. Okay. Then you're going to find the critical numbers. But this is no longer called critical numbers because the relationship between F and F double prime is now like a 2-generation gap. So these now are called possible POIs. Okay, so you would say there's no denominator on this side, so there are no possible POIs. Usually we would say there's no critical numbers, but because the relationship between f and f double prime now is 2 generations, we're going to say no possible POIs. Over here, we're going to either cross multiply or factor. I'm going to go ahead and factor, so take out a 12x. So it's x minus 2 equals 0. So what I get is something times something times something equals 0. So either 12 is equal to 0, oh, that's silly, or x is equal to 0, or x minus 2 is equal to 0, so x is equal to 2. Okay. Do you see what I have so far? Okay, now instead of an f prime number line, guess what I'm going to do? An f double prime number line. Okay, it's the same thing. The names are just getting changed. Instead of putting critical numbers in, guess what I'm putting in? Yeah, possible POIs. Okay, yeah, they're POIs as soon as we verify that they're POIs, but they're not POIs until we verify them. Then you've made 3 compartments. So once again, you're going to plug in, you're going to test some numbers into each compartment. Okay, you guys weren't looking, so I just put 212 up here. And then what you do is you're going to test every compartment. So right here, I'm going to test -1. But where do you think I'm going to test a -1? Do you think I'm going to test it in F, F prime, or F double prime? F double prime. So F double prime, the easiest place to test it is right here. Are you guys good with that? Please do not test it in x minus 2. That's not F double prime. Okay, please make sure you're testing it in something that really is F double prime. And so if you plug in -1, you'll get negative times negative, so that's positive. If you plug in +1, you'll get positive times negative, so that's negative. If I plug in 212, I'll get positive times positive, positive, so that's positive. Are you with me so far? Okay, now here's where it goes different. Okay, when f double prime is positive, what we know, let me write it here. When f double prime is positive, f prime is increasing, but f is concave up. So what I know about f here is that f is concave up. When f double prime is negative, f prime is decreasing, but f is concave down. So what I know about here is f is concave down, and this is f is concave up. Okay, the relationship is a little bit different. Okay, because now we're talking about the relationship between the grandfather and the grandson. Okay, they have a different relationship. It's concave up and concave down. If I wanted to, I could also say the f prime is increasing. So if I wanted to know f prime, it would be increasing. F prime would be decreasing here. F prime would be increasing. It's just that I don't know. I don't want to know about f prime. But if I did, that's what I would do. Okay. So then the question is there a POI at 0 and 2? Are these POIs? You know, they were possible POIs. But to confirm that they're POIs, you have to be changing concavity. Okay, so do you change concavity? Yes. Okay, so let's go back up here and let's do all of our answers. Okay, right here when it says, where are you concave up? Okay, you would say, I am concave up. Please do not write that concave up. Like, don't do this U symbol. Okay, I do it, but you're not allowed to. Okay, you can do it while you're doing the work, but when you present the answer, don't present the answer with a union, because a union and intersection means something else in math. Okay, it doesn't mean concave up and concave down. Okay, so actually write out concave up, and we are concave up between, where is it? Is it negative infinity and 0, guys? Tell me if I'm wrong. Yep. And then also between 2 and infinity, right? What is the justification from concave up? Yeah, you got to do it in terms of f prime, because f prime is increasing, okay? For concave down, again, guys, don't write conc down. Please don't just put an intersection symbol, okay? And that will be between 0 and 2. And what is the justification for conc down? F prime decreasing. I'm getting right here. When f is concave down, f prime is decreasing. If you want, I don't think you want to, but if you do, because some people write this on the AP test, you could write also the slope of f prime is negative. That's also a good justification. But why do that when you just say f prime is decreasing? Okay? All right, where are the inflection points? You would say that inflection points, the POIs are at x equals 0 and x equals 2. And let me just make sure you understand, you can write them separately and do the justification separately. So like at x equals 0, the reason there's a POI x equals 0 is because you've changed from concave up to concave down. So you're actually changing from f prime is increasing to f prime is decreasing. So that's what you would write. You would say because f prime changes from increasing to decreasing. And the justification for x equals 2 will be because, for POI being at x equals 2, is because f prime changes, guess what now? From decreasing to increasing. Okay, and if you go look at the f double prime number line, you could see, so f prime is changing from from decreasing to increasing. You guys see that? Okay? All right, so I'm going to verbally tell you this. I'm not going to write it out because it takes a lot of time. I'm going to verbally tell you this. So see if this makes sense to you. You don't have to write it separate like this. You could write the POI occurs at x equals 0 and x equals 2 because f prime changes from increasing to decreasing and vice versa. Do you see that? Okay, that's another possibility you could write if you wanted to. Okay? You don't have to sketch the graph, so we'll talk about sketching the graph another time. Can you guys move to, I think, the back of your homework? There's like a curve that looks like, let me show you. There's something that looks like this. You guys see something that looks like this? Right? Go ahead and put arrows. These are arrows right here. Okay, this is on your homework. Okay, it looks like this. Okay, and you need to be able to answer these questions. And this is why it gets difficult, because we have always up to this point given you a graph of f. Okay, but you need to know f prime is a person too, and f double prime. Your dad is a person. I know you don't think your parents are people, okay, but your parents are people too, okay, and they have their own curves, okay. So if you have f prime, if I told you f of x, let's say f of x equals, let's just do an easy one, x squared. What would f prime x be? 2x. Well, if I graphed x squared, it would have a curve, right? But if I graphed 2x, wouldn't it have its own curve? Right? So now what we're doing is now we're not always giving you a curve of f. This is a curve of f prime. So everybody good with that? Okay, I'm giving you f prime. Where is f? F is in another room. Okay? So you want to go see my son? You go run to the other room. Okay? But f and f prime have a relationship that you can kind of figure out some things because they have a relationship between them. Okay? So let's look at the first question. The first thing says they're given f prime. Find the critical numbers of f. Okay? You know how to find critical numbers of f. Critical numbers of f happen when f prime is equal to 0 or f prime is equal to d and e, and you solve for the x values. Do you remember that? You solve for the x values. And those x values are the critical values of f. Okay, so let's think this through. But now you're given f prime. Okay, so if you wanted the critical values of f, it would be the x values where f prime is equal to 0. So can you look at your graph and tell me the x values where your f prime is equal to 0? And I'm not going to write the answers on the board just because I want you guys to actually do this on your own. Okay, can you tell me where, and don't worry if you're wrong, it's okay. Okay, your friends will just laugh at you, but I won't. Okay, so where is f prime equal to 0? At what x value? At -3, at 1, and at 5. Do you see that? Those are your critical numbers. Okay. Where is f prime equal to d and e? So this is your f prime graph. So it's just saying, where does your f prime not exist? Where does it not exist? It exists everywhere. We're not talking about the derivative of f prime. Is everybody good with it? Some of you guys look at this and look for the derivative, but this is the f prime graph. So the question is, if this is the f prime graph, if this is your father, where does your father not exist? Everywhere. He exists everywhere. Everybody good with that? So all the domains. So no critical numbers from the D&E. All right, let's answer the second question. The second question is, where does f have a relative max or a min? But remember, when f prime is positive, f is increasing. When f prime is negative, f is decreasing. And you have a relative max on f when f prime changes from positive to negative. And you have a relative min on f when f prime changes from negative to positive. Your picture is F prime. Is everybody good with that? Your picture is not F. So if this were F, you'd say, oh, there's a relative max there, relative max there, relative min there. Is everybody good with that? If this were F, I'm not asking about F, okay? You can't see F. F is in another room, okay? This is F prime. So if you wanted to tell me about F, and you only see F prime, there is a relative max on F when F prime does what? F prime changes from positive to negative. Okay, look at your picture. Where does F prime change from positive to negative? Okay, I got to give you some definitions with you. Positive means above the x-axis. You agree with that? Negative means below the x-axis. You agree with that? Positive and negative do not mean the same. Like positive does not mean the same thing as increasing. You could be positive and decreasing. And negative does not mean the same thing as decreasing. You could be negative and decreasing. Let me show you. Right here, this function is increasing. But is a function positive or negative? It's negative but increasing. You see that? Right here, this function is decreasing. But is it positive or negative? Isn't this number positive? So positive and increasing are not the same things. Is that clear in your mind? Like, it's real easy to think. Think about your calculus grade. It's positive. Is it increasing? No. Okay? You can be positive and decreasing, right? Okay, they're not the same thing. Okay, so knowing that, okay, let's start all over again. Okay, we're trying to find where the relative max on F is. The relative max happens when F prime, when this graph changes from positive to negative. Where does this graph change from positive to negative? It's only at one point. X equals 5. Is everybody good with that? What is happening at x equals -3? F prime is changing from negative to positive. When F prime changes from negative to positive, what's happening there? That's a relative min on F. Is everybody good with that? So if I asked you where the relative min on F is, you would say at -3. Okay? What about right here at x equals 1? Nothing. Everybody good with that? F prime is changing from positive to positive. There is nothing when you say F prime changing from positive to positive. Okay, nothing happens. Okay, finally, they ask you, where is F concave down? Okay, again, you do not have an F curve. Okay, so you cannot look at this curve and figure out what's going on with F. If you wanted to see F, you'd have to go run to the other room. But you know some relationships, okay, between F and F prime. And that is when F double prime is positive, F prime is increasing and F is concave up. When F double prime is negative, F prime is decreasing, F is concave down. When you move between these two rows, you have a POI. Do you see how important this is becoming? Okay, let's look at this. When you want to know if F is concave up, okay, what is it synonymous to? F prime is increasing. Isn't that the curve I have, the F prime curve? Can you go look at the F prime curve and tell me the intervals where F prime is increasing? Where is F prime increasing? Jot it down on your paper. Where is F prime increasing? Because that's where F is concave up. Okay, remember these are arrows here. So I'm getting all of this right here, and also all of this right here. Are you getting the same? That is where F is increasing. Okay? So you guys tell me, and you guys tell me what your answer is. Where is F concave up? From -infinity to -2, and also from 1 to 4? Is that what you guys got? Okay. And then where are you going to be concave down? Do you think you could do that on your own? Okay, so I'll let you guys do that on your own. All right? So you need to be thinking about these relationships as you do number 5 and 6. And AP asks a lot of questions like this. And we'll be doing more of these, I think, in about 2 more units. Okay? But this is kind of a head start, okay, so that you can start liking these already. All right, let's go to your homework from last night. I know a lot of you guys had trouble with the last problem. And so I'm just going to go ahead and set up that derivative for you, and hopefully that'll make you a little bit happier. I don't know where it is though. Okay, this one might work. Okay, so this is from your homework last night. I think we have still 2 minutes. Okay, let me just set this derivative up for you. I'll go as far as I can. I think it'll make you feel more comfortable at least. All right. All right, guys. When you take the derivative of this right here, this is raised to the 1/2. Okay. I'll be here during demo period after school today, FYI, so people who need it. You're going to take the derivative of the first times the second, and the second is just the way it is. Okay. Then you're going to add that with the derivative of the second. Well, the second is this component right here. So what you're going to do is you're going to do 1/2. Leave the inside alone. Leave him alone, guys. Take the power down by 1, but don't forget to multiply by the derivative of the inside. But what students forget is you also have to multiply by the first, right? Because that's the formula. It's the derivative of the first times the second plus derivative of the second times the first. Okay? What's going to happen is these 2's are going to cancel out because everything here is being multiplied. So the 2's will cancel out. So this will be equal to the square root of 9 minus x squared. You're going to have positive times negative times positive. So that's going to be negative. X times x is x squared. So that's going to be in the numerator. And in the denominator, I'm going to move this 1/2 right down to the denominator so that I can get a positive exponent. When I do that, do you guys see that this is the same thing as making this a square root? Okay, so that's what I get. So I'm going to delete this thing. This is a square root. So this is the first derivative. I'm going to set this equal to 0, and I'm also going to set this equal to d and e. Okay. When you set this to d and e, all you're saying is what will cause this thing to not work out. Okay. And what causes the thing to not work out is anytime you see a denominator, it cannot equal to 0. That's what will cause this thing to work out. So you always just set denominators equal to 0 to find the critical values on the d and e side. So if you square both sides, what you end up getting is that x is equal to plus or minus 3. And that's what I'll end up putting into my f prime number line. Okay. Over here, guys, you're going to cross multiply. I'll put my answers online, and you guys can work that out.